Quicksort. Quicksort is also known as partition exchange sort. This algorithm works by using a divide and conquer strategy to divide a single unsorted array into two smaller subarrays. The quicksort algorithm works as follows. Select an element pivot from the array elements. Rearrange the elements in the array in such a way that all elements that are less than the pivot appear before the pivot and all elements greater than the pivot element come after it. Equal values can go either way. After such a partitioning, the pivot is placed in its final position. This is called the partition operation. Recursively sort the two subarrays thus obtained. One with sublist of values smaller than that of pivot element and the other having higher value elements. After each iteration, one element, pivot, is always in its final position. Hence, with every iteration, there is one less element to be sorted in the array. Now let us look at the algorithm of quicksort. Here, low is the starting index, high is the ending index and pi is the partitioning index. The main task is to find the pivot element, which will partition the array into two halves. To understand how we find the pivot element, and how the array is divided into subarrays, let us see the partition algorithm. Pivot is the element to be placed at right position. And here we are picking the last element as the pivot element. So ARR of high becomes the pivot. The variable I is the index of smaller element and indicates the right position of pivot found so far. Now we start a for loop from low to high -1. Inside the loop we are comparing if current element is smaller than the pivot. If yes, then increment index of smaller element and swap ARR of I and ARR of j. If no, then increment j and again enter the loop and compare ARR of j with pivot. After coming out of the loop, swap ARR of I and pivot, that is ARR of high. And at last we return the current value of I plus 1. Now let us take an example of an unsorted array and try to sort the array using quicksort algorithm. So this is the unsorted array and this is the index of elements. Now let us look at the first pass, that is when the partition algorithm is called for the first time with low equal to 0 and high equal to 5. After the first pass, the pivot, which is 5 in this case, will be placed at its correct position. Now with pivot as 5, low as 0 and high as 5, the partition algorithm is called. The for loop starts with j equal to 0 and compares jth element of array with the pivot. For j equal to 4, the comparison result is true and thus I is incremented by 1 and we swap ith and the jth element, that is 10 and 1. For j equal to 5 we are out of the loop and we have to finally swap the I plus 1th element of the array, which is 7, with the pivot, which is 5. After first call of partition algorithm, the pivot is placed at its correct position. And the array is divided into two subarrays, right subarray and left subarray. Finally we return I plus 1, the right position of pivot found so far, which is 1. Now quicksort will be again called for the left subarray, and as we can see here that there is only one element in the left subarray, which is an already sorted element. Next quicksort will be again called for the right subarray with low equals 2 and high equals 5, and the pivot element will be ARR of high, that is 7. Now the partition algorithm will start with j equals 2 to j equals 4. For j equals 5 we will be out of the loop and we have to swap the I plus 1th element and the pivot, which are 8 and 7, and finally return I plus 1, that is 2. Next the quicksort will be called again, and in turn it will invoke partition algorithm again with low equals 3 and high equals 5. And the pivot will be ARR of high equals 8. Now the partition algorithm will be called with j equals 3. For j equals 5 we will be out of the loop and we have to swap the I plus 1th element and the pivot, which are 9 and 8 this time, and finally return I plus 1, that is 3. Again quicksort will be called and in turn will invoke partition algorithm, but now with j equals 4. For j equals 5 we will be out of the loop and we have to swap the I plus 1th element and the pivot, which are 9 and 10 this time, and finally return I plus 1, that is 4. Finally we get sorted array using quicksort algorithm. Worst time complexity of quicksort is O(n) square and best and average case time complexities are O(n) log n. It is faster than other algorithms such as bubble, selection, and insertion sort. Quicksort can be used to sort arrays of small, medium, or large size. On the other hand, quicksort is complex and massively recursive. Please like, share and subscribe and press the bell icon to get updates for more videos.